On the next page, we're going to put both example number 1 and example number 2 side by side. Let's first focus on example number 1. Example number 1 asks us to graph this hyperbola. One of the first things we need to make a decision about is which way is this hyperbola going to open. What we do know is that we're starting off with y squared, so it's going to actually go up and down like the y-axis. So the equation actually tells you that it's going to go like the y-axis away from the x-axis. So we're going to use that information in order to finish our graph. In order to get started, we're going to go find our center. Our center is going to be 2, -3. Just want to remind you that your x coordinate for your center will be located with the x's, and the y coordinate for your center will be located with the y's. The next thing we need to do is go find little a, little b, and little c. Notice that little a is always written first, so we're going to find that to be 2, because the square root of 4 is 2. We're going to find b to be the square root of 9, which is 3. To find little c, we're going to use the relationship that c squared is equal to a squared plus b squared. Remember, we want c to be bigger than a, so that's the reason why we're adding. So a squared is 4, b squared is 9. When we add them, we get 13. So c is the square root of 13. Because we're graphing, we need to estimate that as 3.6. I think we're ready to graph. So one of the things we're going to start off with is our center. Our center is going to be at 2, -3, so that's going to be right here. And I'm going to go ahead and label that as the center. Then we're going to go A, which is 2, in the up and down direction. So I'm going to go up 2 and down 2. Remember, those are our vectors and vector primes. Then I'm going to go 3 left and right. And again, we can see that the 9 is underneath the x's, so that says to go left and right. So I'm going to go 3 from the center, 1, 2, 3, to find Bob, and then 1, 2, 3 to find Bob prime. We're going to make our box, and to make our box, what we're going to do is find just the corners. So I'm going to come and find that one of the corners is right here, the other corner is right here, the other corner is right here, and the last one will be right here. We're only interested in the corners because that's going to be the how we're going to make our asymptotes. So to make our asymptotes, we're going to start from one corner, go towards the center, out the other side, going that way. And while we're here, we can find our slope. Notice we're going to go up 2 and over 3. So I can go to this point, go up 2 and over 3. Or we can go down 2 and over 3. And down 2 and over 3. Down 2 and over 3. So we can get those asymptotes. I'm going to write that down, that the slope that we found was up 2 and over 3. Alright, those are the slope of the asymptote. The next thing we need to do is to go find our focus. We're going to go 3, just like we did the A. So we're going to go up and down from our center of 2, 3.5. And then we do the same thing going down, so 2, 3.5. So this is our focus. These points that we just found here. We're going to go ahead and find our lattice rectum. Remember that our lattice rectum is equal to 2b squared over a. In our case, it's going to be 2 times 9 over 2. So we're going to find that our lattice rectum is equal to 9. So from my focus, I am going to go over 4.5. Why 4.5? Because we're going to go half in one direction. So from here, I'm going to go over 1, 2, 3, 4.5. So from here, I'm going to go 1, 2, 3, 4.5. From our focus, we're going to go 1, 2, 3, 4.5. 1, 2, 3, 4.5. Okay, so to finish up our graph, we're going to start at the vertex to our lattice rectum point and then towards our asymptote. Vertex, lattice rectum towards the asymptote. Vertex, lattice rectum towards the asymptote. Same thing over here. And that is our graph of our equation of our hyperbola. So the only thing that we can do now is actually go find those values of everything. So remember that we're going to be asked to find coordinates of the vertices, coordinates of the foci, as well as equations of the lattice rectums. Equation of the asymptotes. So let's make sure we can do that information. So we know that our center was at 2, -3. To find our vertices, we went up and down. So we're going to go 2, and then with our -3, we went plus or up 2, and then we went down 2. So we're going to find that our vertices were at 2, -5, and at 2, -1. And we can see those from our graph as well. To find our foci, we're going to do the same thing. We're going to get -3, and we're going to add and subtract the square root of 13. So we're going to find our foci to be at 2, -3 plus the square root of 13, and at 2, -3 minus the square root of 13. And last but not least, our job is to find our equations of our asymptotes. We're going to use the slope form, so we're going to do y minus the y coordinate of our center. So it's going to be y minus -3, which we can rewrite that as y plus 3 in a minute. We're going to do plus or minus our slope, which we found over here. And then our x minus our x coordinate, which is 2. And we're going to leave it like this. The only thing that might be different is that my math lab may ask you to write these separately. But remember, we're going to have y plus 3 is equal to plus or minus 2/3 x minus 2. And I would be happy to have that as the equation of our asymptotes. For example number 2, we're given information, and our job is to find the equation. If we know what the center is, we know what the focus is, and we know what the vertex is. Like we have done in the past, graphing what we know will help us make our decision on which way our graph is going. So let's make sure we do that. So we're going to graph our center at -2, +1. That's our center. Our focus is at -2, +4, and our vertex is at -2, +3. So just by that, we can see that this equation, or this graph, is going to be opening up and down, because we can see our vertex is above our center, and more importantly, our focus is above that. So we know that it's going to be up and down. So for up and down, we're going to have our equation to be y minus k squared over a minus x minus h squared over b squared is equal to 1. This one should also be squared. So that's our equation. We just need to start filling it in. We know our center, so we know that we're going to have y minus 1 squared minus x plus 2, because remember that's x minus a -2 squared is equal to 1. We got to go find a squared and b squared. But from our graph, just from our points that we have, we can see that from our center to our vertex is 2, and that is a, so we know that a is equal to 2, so a squared is equal to 4. We're going to do the same thing for the focus. The focus is from the center to the focus, and that's c. So we know that c is equal to 3 because we went up 3 units. But I don't need c, I need b, so I can find b squared. So we're going to use our equation of c squared is equal to a squared plus b squared. C squared is 9, a squared is 4. Solving, I'm going to find that b squared is equal to 5. And that's what we need for our equation. And we're done with our equation since we found everything we needed. But also note that b is equal to the square root of 5, which is also approximately 2.2. Now, why am I doing that? So that we can finish graphing and practice in our graphing. So let's graph the other vertex. So we go down to the other focus. We also need to find our b is 2.2. So from our center, we're going to go 2 and a little bit, and 2 and a little bit, 1, 2 and a little bit. Those are our bobs and bob primes. Remember, we're going to be looking for just our corner points of our box. So corner points of our box. And you can go to the vertex and then go 2 and a little bit, just like we did for our bobs. And you can see that that's going to be our box and our rectangles that we need to go find its diagonals. So for our diagonals, we're going to go from one box to the other. We're going to do the same thing over here. So now that we have that, those are our asymptotes. We can go from the center to one of the boxes so that we can find our slope. So we went up 2, and then so our slope was we went up 2, and then we went over the square root of 5, or 2.2. So we're going to go ahead and leave that as our slope for our asymptotes. Let's go ahead and finish graphing our we're going to need lattice rectum. So lattice rectum is equal to 2b squared over a, which is 2b squared was 5 and a was 2, so we're going to get 5. So that means I need to go half one way and half the other. So at my focus, I'm going to go over 2 and a half, 1, 2 and a half, and I'm going to go over 1, 2 and a half. And you can see that it's really close to my blue asymptotes. And I do the same thing at this focus. I go over 1, 2 and a half. So from my vertex through that point, through my asymptotes. So I go over 2 and a half from my vertex through that point through my asymptotes. So we have finished graphing it. For our asymptotes, our equation is going to be y minus 1 is equal to plus or minus 2 over the square root of 5, x plus 2. This is the equations of our asymptotes. And that concludes this video.